Ooh, hello. Okay. All right. So this is the practical test review. All right. We're going to start with practical test one. Ooh, look at my cursor. Doing, doing, doing. Sorry. Okay. Instructions. Blah blah blah. Most important thing over here. Please don't forget to upload your attachment. All right. I'm looking at you, person who didn't upload your attachment and got 0. Okay. Luckily for him, we managed to find the thing and verify that he hasn't changed it, so don't count on that. Okay, alright, so the first question is Easter. Okay, so we give you a formula. Alright, we give you a bunch of parameters. Okay, the formula works in these years, alright, except for these. So in your mind, as you're reading through this, my cat's playing with stuff again. In your mind, as you're reading through these, you should be like, alright, this is a certain condition, alright, let's check for this one condition, alright, and then let's check for this other condition. And then, because of this condition, let's do this. Alright, my mouse is nuts. Whee! Alright, and then follow the rest of the instructions. Okay, so bit by bit. Alright, let's do it bit by bit. Alright, so I'm actually going to code this for you. Okay, I'm actually cheating because I have the answer by the side, but let's pretend that I'm doing this live. Alright, so first of all, there are all these formulae. Alright, but never mind those first. First of all, you need to ask the user to input a year. Alright. So first things first, you need to try and get a year. So year equals to input, what year do you want to check? Alright, and because we want this to be an integer, we convert this to an integer. Okay, alright. Then first things first, let's see. This only works between 1900 and 2099. Alright, so verifies that it's the proper range. If it's not, it's okay to quit and ask the user to restart the program. Okay, so sure. If year less than 1900, or year greater than 2099, alright, then just print. You fool! That's an invalid year. Alright, fine. Let's tell them more things. What year between 1900 and 2099 do you want to check? Okay? Bye! Alright. Okay, so this is one way to not run the program if you don't meet the criteria. Okay, some of you will have asked me, how do I exit? Right? How do I exit from here? Alright, I can't return, can I? Okay, so maybe you can return, right, if you put in a function and everything, but no. Alright, let's just say if the year is invalid, you print something and they don't get anything else. Alright, everything else will be inside the else statement. Okay? So now let's use this formula. Alright, I'm actually gonna copy and paste. I'm gonna copy and paste carefully. Oh man. Alright, forget it. I'm not going to copy and paste. I'm going to type this out as quickly as I can. What in the world? What's this one? Stop it. Alright, A equals to year mod 19. Alright, B equals to year mod 4. C equals to year mod 7. Feel free to skip ahead until I finish typing this. D equals to 19 times A plus 24. Alright, those of you who managed to copy and paste it, you do realize that you have to add times yourself, okay, because that's just not something that Python recognizes. You don't need spaces between times. You can do this if you want, alright, whatever's clearer for you. Mod 7, okay, so A, B, C, D, E, and then the date of Easter, alright, day is equals to 22 plus D plus E, alright, and let me put a note here that says could be in April, okay, so day is March 22 plus D plus E. What is it about recording videos that makes my cat wants to play with a toy? She was fine before this, she was sleeping, but now she wants to play with a pen that she found on the floor. Okay, anyway, alright, so first things first, okay, you're done, alright, you're done, but there are two conditions I have to check. First, you have to check for the 1954, 1981, etc. And then after that, you have to check if it's in April. Alright, you should think to yourself, which of these do you need to do first? Alright, the 1954, 1981, etc., all these dates, these will produce a date that's 1 week too late. Alright, too late means you have to shift it back by 7. So you should do this first before you check if it's in April. Alright, because what happens if, on these days, if you end up with, April the 2nd, alright, April 2nd, 1954, alright, in that case, if you don't subtract 7 days, you go ahead and say, oh, it's in April, I'm going to print, I'm going to mod 31 and print April 2nd. And then you check for whether it's in 1954, and you minus 7, you're going to end up with a negative number. Alright, hope that makes sense. Okay, so if year equals to 1954, these parentheses are not necessary in Python, but I like them because it just makes it look cleaner, or year equals to 2049, or year equals to 2076. Okay, you can't see it, but it's off the screen. But you know, assume that I'm typing things properly. Okay, it's 7 days. It's 1 week too late. All right, too late. That means you get a number that is bigger than it's supposed to be. In which case you subtract 7. All right. So, now we worry about whether it's in April. Okay, so one way to say is that if day is less than or equals to 31, all right, that means it's still in March, right? So you print March of day. Okay. Else, all right, in this case it's in April. It's in April, right? So if something and then else, all right. If it's not less than or equals to 31, it must be greater than 31, right? If it's greater than 31, therefore new day equals to day mod 31. All right, the remainder when you subtract 31 from it, then you say print April of new day. Okay, you don't need a space here because comma already adds a space for you. Okay, so I'm gonna run this. Let me save this somewhere. Potato. Okay, let's say 1991. Alright, so March of 31. Alright, that's actually not so great. Maybe I might want to say March 31st. Okay, we are not strict about how you print things out. Alright, so notice I print like this here, here it's like that. Alright, don't worry about that. Okay, this is not something that bothers us greatly. Okay, alright, let's number 1. Let's move on. Let's see how many I can fit in like 15 minutes. Okay, so alright, we're done with this. Let's move on to the next one. The next one is GCD, the question which killed everybody. Alright, this is the marking scheme. I'm going to put it to the side so I can refer to it while I type, because who wants to do this like bit by bit, right? Okay, I have to admit that this one stumped me for a moment when I was doing it myself. Okay, so important thing, right, is to read through the question carefully. Right, read through the question carefully. First of all, understand what they're asking for. Right, understand. Right, over here it says write a function. Right, it takes in 2 numbers and returns a divisor. So over in the previous question, we didn't ask you to write any function. Right, no functions printed here. Over here, you actually have to write a function which takes in 2 things and returns a number. All right, so that means if you have a GCD that does this, GCD PQ. All right. And you do a bunch of calculations, and then you say print the GCD is GCD. All right. Let's say you manage to find GCD equals to 1, whatever lah. All right. And if you do this, you're going to lose a bunch of marks. All right. You're going to lose a bunch of marks because you're not following the instructions. The instructions say the function has to return the GCD. That means that someone out there is going to say print GCD 18266415485. Alright, they're going to expect a number to be returned from this, and they want to print it out themselves. Alright, they're not asking you to print it out. Alright, this for some reason is tripping up a lot of you. Alright, so I just want to make this very clear. What should happen here is that once you find the GCD, you return the GCD, you don't print anything. Okay? Alright, so now let's actually get around to finding GCD. Okay, so this is the example. Alright. From the larger number, subtract the smaller number as many times as you can until you have a number that is smaller than the small number. Alright, so another way of putting this is subtract the small number as many times as you can without getting a negative result. Okay? Now, using the original small number and the result, a smaller number, repeat the process. So, let's say 1, 2, 0, and 50. You figure out which one is the bigger number. Alright, you subtract the smaller from the bigger until there is nothing left. Okay? So you know what? I'm going to make this slightly easier on us. Let's start by trying to figure out if P is less than Q. Alright, if P is less than Q, alright, what are we going to do? That means if P is less than Q, right, P is the smaller number, I'm going to subtract Q, I'm going to subtract P from Q. Agree? Alright, you know what? Yeah, let's do it that way. Okay, so if P is less than Q, I'm going to subtract P from Q. And I want to do this many, many times. Does that make sense? I want to do this many, many, many times. Okay, so I want to have this in a while loop. Alright, I don't know what's in a while loop. I'm going to use this thing called while true. Okay, this says that while true, alright, if P is less than Q, I'm just going to keep subtracting. Okay, so imagine, alright, if let's say I get 120 and 50. Alright, 50 and 120, okay? 50 and 120. Alright, so let's say, so for GCD of 50 and 120, 50, 120, that means P is equals to 50, Q is equals to 120. Alright, so while true, if P is less than Q, yeah, it is, right? P is less than Q, 50 is then, therefore Q equals to Q minus P. Alright, so I'm going to say Q used to be 120. Alright, so now Q equals to 120 minus 50 equals to 70. Next, the second time round, alright, so the first round, this is what happens, right? Q is equals to 70. Second time round, alright, second round, Q is equals to 70 minus 50 equals to 20. Right, and at this point, okay, at this point, oh, this actually isn't going to happen anymore, right? The next round you come here, P is no longer less than Q. Then you're actually into the next line. Into the next line, and the next line what happens? You're actually swapping P and Q, right? P has become the larger number, and Q has become the smaller number. So we're going to swap them. Okay, so let's consider this. So else, alright, we've reached a point when Q is smaller than P. What do we want to do? We want to swap them. Let's swap the two of them. Okay, so if you remember how to swap, you need to say, have a temporary variable, temp equals to P, P equals to Q, Q equals to temp. Alright, this one I've gone through in class. Alright, this is one of the ways you can swap two variables. You need an extra thing elsewhere. Yeah, again, computers are not like, programming languages are not like us, right? If we know that P is 50 and Q is 120, mentally we know how to switch them. Alright, computers can't do this. They can only do one thing at a time. Alright, so that's why you have to store temp somewhere. So now temp is equals to 50, right? And oops, sorry. Let's see. And now P is equals to Q, which is 20. And now Q is equals to 50. Okay, so never mind what temp is at the end of this, right? All we know is that the next round, we come back into this while loop, right? The next time we get back into this while loop, right, the next round in this loop, P is now less than Q. Alright. In which case, alright, the fourth round, right, because the third round was a swap, right? So third round, swap. Alright, fourth round, alright, Q is now equals to, right, Q minus P equals to 30. Fifth round, alright, Q is equals to 30 minus 20 equals to 10. Alright, and then you can imagine, alright, because now P is no longer less than Q, alright, Q is 10, alright, let's say P is equals to 20, here P is equals to 20, alright, here P is equals to 50, here P is equals to 50. Okay, so at this point, Q is 10, P is 20, P is no longer less than Q, so we swap. Alright, so fifth round, sixth round, swap. Then we have reached this point. Alright, we reached this point, seventh round. Alright, we know that we have swapped, so now Q is equals to, Q is equals to 20, P is equals to 10. Alright, so Q is equals to 20 minus 10 equals to 10. So far so good, P is equals to 10. And eighth round, okay, Q is equals to 10 minus 10 equals 0, P equals to 10. Okay, so at this point, alright, repeat until the last result is 0. Okay, so after the 8th round, we have to stop. Right, I've just gone through this entire sequence for you. Right, this entire sequence. First round is this, second round is this, third round is this. Okay, but we haven't managed to find a way to exit the loop. So the exit condition is that repeat until the last result is 0. So essentially, while Q, alright, not equals to 0. Okay, so the moment Q is 0, right, you're done. That's it. Alright, you have found the greatest. You have found the greatest common denominator. Right, what is the greatest common denominator at this point? Alright, the GCD is the next to last small number result. In which case, it is actually what is it? P. Alright, the next to last small number result, P. Okay, alright, so I'm just gonna save this and let's not use this yet. Let's say we have a greatest common divisor of 60 and 12. I believe that's 12, right? So we run this, okay. I made a mistake. Oh no, what happened? Okay. While Q not equals to P. Okay, that works. All right. So while Q not equals to P, all right, you keep running it. Why did it not work? Hang on, let me check. All right. So at the 8th round, Q equals to. Oh, sorry. Okay. So what happened is that. Oh, I see. Okay. Because over here in the 7th round, Q is equals to 10, P is equals to 10. All right. It actually does. This thing doesn't work anymore. So I ended up with an infinite swapping loop. All right. So what I did was I short-circuited the process, okay, and I said, while Q is not equals to P. Right, the moment they're the same, all right, then there's nothing left to do, lah. All right. Another way is to perhaps while Q not equals 0, if P less than or equals to Q. All right, this should work. Also 12. All right. Thank goodness. Whew. Okay. All right. So hopefully this explains this gigantic thing. There are other ways to do it. Okay. You can also use recursion. All right, because I just taught you guys recursion. You can think about how you are going to use that. All right, you can use modulo. You can use the modulo somehow. All right, because 120 modulo 50 will give you 20. All right, 50 modulo 20 will give you 10. So you actually don't need this while loop. You might not need this kind of while loop, essentially. All right, so there's another way of doing it. I'll let you find out I'll let you figure out how to do it. Okay, and these things over here, use your function to find the GCD. Well, you need to essentially find the GCD of these two. Alright. Find the GCD of the result. You essentially need to find the GCD of these two and the GCD of these two. Okay, so this and 2, 8, 3, 8, 4. Alright. And that is your answer for part 1. Alright, reduce the fraction. Alright, this just means you find the GCDs and then divide them away until you get the lowest terms. Okay? So all this, I think, if you manage to get the GCD question, you should get the answer. Alright, 16 minutes. Stop.